Today we're going to look at number patterns, and the first question is, if you consider this sequence that's in the orange box, what is the rule? It's not a very good question, what is the rule, because there's more than one correct answer. But I'll ask you anyway, what do you think? What is the rule? Have a think. Maybe you have an answer a bit like this. And if you did, well done, that is of course correct. Maybe you were a bit more specific and said something like start with 16 and then add 3 each time. I'd be surprised if you said the following, but the next thing I write is also a correct answer. So do 3 times by the term you want, then add 3. I'll quickly explain why this is indeed a correct answer. So what do I mean by the term that I want? Well, we can call these by name. So the 16 is the first term, second term, third term, fourth term, and so on. So we already know the fourth term is 25, but let's work it out using this rule. Do 3 times by the term that we want. Well, if I want to work out the fourth term, then the term I want is 4. The fourth term is so number 4. So 3 times the number 4, the fourth term, and then add 13. Okay, well, 3 times 4 is 12. 12 add 13 gives me 25. Yes, that does seem to work, doesn't it? So this rule, we've just worked out the fourth term by multiplying 4 by 3 and then adding 13. And yes, that did indeed work. I'll try another one. This 31 is the sixth term. I mean, I already know it, so you wouldn't normally bother working out things that you already know. I'm just trying to demonstrate that this rule actually works. So let's do it then. If I want the sixth term, the rule says do 3 times the term. So 3 times 6, 3 times by the term I want, and then add 13. Okay, well, 3 times 6 is 18. Add 13. 18 and 13 makes 31. Yes, that does seem to work, and it works for all of them. Doesn't matter which term you choose. If you multiply the term number by 3 and then add 13, you do appear to get the correct answer. Now, suppose I wanted to jump to, say, the 100th term. Right, if I said work out the 100th term in the sequence, then one of these rules is more useful than the other, if you think about it, because this one, if I just kept adding 3's, which is true, so I know the next one's 34, then it's 37, then it's 40, and so on. To keep adding 3's would take me ages and ages and ages. I need to get the 7th term, then the 8th term, all the way up to the 98th, 99th, and then finally the 100th term, and I'd have my answer. So this is not a particularly useful rule, although it's correct. It's not particularly useful for working out some sort of random position in the sequence. This one, however, is ideal. If I wanted to go to the 100th term, no problem. This rule is perfectly happy. So the 100th term in this sequence, I've got to do 3 times by the term. So 3 times 100. Okay, the term I want is the 100th term, so 3 times 100, add 13. I don't think you need a calculator for that. That's going to be 313, isn't it? 313 will be the 100th one in the sequence. You need to be aware that we have some names here. Both of these rules are correct, but they sort of do different things. This one over here is called a term-to-term rule. Because if I know, say, the 6th term, if I do the rule, I get the 7th term. Okay, so I know the 6th term is 31. I'll do the rule, add 3, get 34. So the 7th term is 34. I get from 6 to 7. 6th to 7th term. If I were to tell you that the 100th term is 313, but I want the 101st term, just add 3. Okay, that's the term-to-term rule. 316 would be the 101st term. That's the term-to-term rule. This rule over here is what we call a position-to-term rule, because I can specify any position in the sequence I like. Position term rule. Any position I like I sort of jump straight to the 100th term, and the rule didn't mind. It would jump to any particular place in the sequence that I like. So the tricky thing for us is going to be, can we work out the position to term rule? Because really, this is the one we care about now. Most of the rules you played with at primary school, or maybe in the Kent test and things like that, would have been term-to-term rules. We are now far more concerned with position-to-term rules. Okay. Now it turns out that there is, in general, a little rule that allows us, sorry, I should say like a formula that allows us to work out this kind of thing. I told you the answer here. I said, oh, by the way, the rule is, do 3 times the term number, then add 13. But where has that come from? Was not totally random. Notice in this sequence, it was going up by 3 each time. So 16 add 3 is 19. 19 add 3 is 22. 22 add 3 is 25. So it's going up by 3 each time. Okay, do 3 times blah, 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 blah. And you might have noticed this one's a little bit more buried. If I work out the term that came, not in the sequence over here, but the one that came before the 16, okay, so that would have been, you add 3 to something to get 16. The one that comes before the 16, well, that would have been 13, and that's that number there. So it's not completely random. This number is in the rule because that's what it's going up by, and this number is in the sequence because that's the one before the first term. We call this the difference. 3 is called the difference, and the 13 is called the 0 term. Okay, 0 term. Because remember, that was the first term, second term, third term, fourth term. So it makes sense then that the one before the first term is called the 0, or 0th term, if you prefer. So in fact, my position to term rule will always look like that. It will always be whatever the difference between the terms is times by the term number that I actually want, and then add on the 0 term. It looks a bit confusing when it's written generally like this, but for any particular example, it's pretty easy. I'll show you how it works with a few more examples. Right, so here are a few more examples. Let's look at number 1 then to begin with. Here's a sequence. It appears to be going up in 5s, doesn't it? Here's a sequence. And quite simply, I would just like to know the 6th term in the sequence. I also want to know the 50th term in the sequence. I also would like to know the 100th term in the sequence. Okay, so I've got the first term, second term, third term, fourth term, fifth term. Well, the 6th term is fairly easy then. That just comes next. It's going up in 5s, isn't it? Well, 5 more than 27 is 32. So the 6th term, no effort at all. I've just used a term-to-term rule there, where you just add 5. Okay, it's just add 5 each time. Now I suggested that was add 5. So using my colours and using this formula, it says add 5, add 5, add 5, and so on. If I want to jump straight to the 50th term, I'm not going to keep going add 5, add 5, add 5, add 5 all day until I eventually get to the 50th term. I'm going to use this rule down here instead. Okay, I'm going to use the difference times term number plus 0 term rule instead. So to jump straight to the 50th term, I know the difference between terms is 5. Okay, it's just 5. I know the difference between terms is 5. The term number here is, well, 50. It's the 50th term is what I'm trying to find. Okay, so that varies depending on what term I'm trying to find. If I want the 50th term number is 50. And this last term is the 0 term. That was the one that comes before the first term. Well, before the first term would have been 5 less than 7. That would have been 2, wouldn't it? Surely 2 would have come before the 7. That's positive 2, so plus 2. 5 times 50 is 250. Add on 2, I get 252. So the 50th term for the sequence in number 1 is just 252. In the same way, I could work out the 100th term of the sequence. So the difference is, just using this rule, difference is 5. The term number I want this term is the 100th term. So 5 times 100. And the 0 term for the sequence we worked out was 2, positive 2, so plus 2. 5 times 100 plus 502, isn't it? So can you see how I've been able to jump straight to the 100th term in the sequence by using this rule down here? I'll do the others then. So in question number 2, if I want to get to the 6th term, I've got the first, second, third, fourth, fifth. To get to the 6th term, note that this is going up at 6s, isn't it? You're adding 6 each time. This is plus 6, plus 6, plus 6. And so it's always going up in 6s. So if I just add another 6 to the 28, I'll get 34. So 34 is the next one, the 6th term in the sequence. But if I want to go to the 50th term, I'm not going to keep doing plus 6, plus 6, plus 6. I'm going to use this rule down here instead. Use this one. So the difference is 6. I want the 50th term here. Okay, that's the one I'm trying to find. So the term number is 50. What's the 0 term for this sequence? Well, it's going forward, it's going up in 6s. Well, 6 less than 4 is minus 2, isn't it? Okay, if you add 6 to minus 2, you get 4. So the 0 term for this one is minus 2. Therefore, 6 times 50 minus 2. You can put add minus 2 if you like. No need. If you add minus 2, that's the same as taking away 2. So what do I get? 6 50s are 300. Take off 2, 298. So I think there the 50th term in question number 2 is 298. For the 100th term, that same idea. It's 6 times 100 this time. Okay, 6 because it's the difference, 100 because it's the 100th term. We've already worked out the 0 term as being minus 2. Like I said before, you can write plus minus 2 if you like, but no need. 6 times 100 is 600. 600 take 2 is 598. Okay, 598. In question number 3, this sequence is going down in tens each time. So you could suggest that we're adding on minus 10 each time. So we wouldn't say the difference is 10, the difference is minus 10 for this one. Okay, so the next one in the sequence with 10 less than 10 is nothing. So that's a nice easy one. But the 50th term is a bit more complicated. We said the difference was minus 10. We're trying to find the 50th term. The 0 term here, the one before 50, would have been 60. So add 60, positive 60, so add 60. You can use a calculator for this if you like. Minus 10 times 50 is minus 500, and minus 500 plus 60 is minus 440. But like I say, you can use a calculator for that if you like. The 100th term, well, that we know it's minus 10 for the difference. I want the 100th term, so times by 100 for term number. And the 0 term is 60, positive 60. Minus 10 times 100 is minus 1,000. Add on 60, so minus 940. Like I say, you can use a calculator if you like. I will do the last example. In this one, you can see it's going up by 0.05 each time. Okay, 0.05 each time. If I add 0.05 to this, to get the 6th term, that's 0.85. But if I want to jump straight to the 50th, I'll use this rule down here. Well, the difference we've just discussed is 0.05 times by 50 for the 50th term. The 0 term here, the one before this, would have been 0.55. 0.55 would have come before. Maybe I will use a calculator for this one, but I'll see if I can do it in my head first. So I know that this is... okay, let's use a calculator for this one. So 0.05 times 50. 0.05 times 50. I need the 0 term still, don't I? The 0 term was at 0.55. So just check you can see that on the screen. Yep. So that was the difference times the term number. Add on the 0 term. So it comes out as 3.05. The 50th term is 3.05. Okay, even after all that, even after the 50, it's only up to 3 and a bit. Okay. For the 100th term, 0.05 times by 100, because the term number is 100. 0 term we said was 0.55. Might be able to do this one in my head. 100 times 0.05 is just 5. 5 add 0.55 is 5.55, all the 5s. Okay, so simply put, this rule down here, difference times term number or 0 term, is what we call a position to term rule. It allows us to jump straight to a point in the sequence. For number 1, you could have said, yes, the rule is add 5 each time, and that's true. But add 5 is what we call a term to term rule, whereas times the term by 3 and then add 2, that's our positioned term. We can get to any point in the sequence we like by using this, the difference times term number adds 0 term. Okay, good luck with these.